Well, welcome to this session that I've entitled Beyond the Basics, Object Level Security on IBM, which is a topic I think is often skipped around and I think is an important tool in your tool bag of IBM security controls. I know most of you know me already, but if you are new to the Health Systems webinar series, my name is Robin Tatam. I'm the Director of Security Technologies here, and I've been with Health Systems now for going on 13 years, unbelievably. I'm one of the several IBM champions on staff, and while I have made my career on the Power Systems platform starting back in the AS400 days, I'm also a certified auditor, so I do a lot of work around audit and compliance, and I wanted to share some of that knowledge with you here today. The big question we always ask at the beginning, and I still occasionally hear from people, is why should we bother with security? It's more a nuance around this platform. I think we all understand why security is so important in general, but there is an acceptance that the firewall is going to protect us from any type of attack that we may experience. So why do we need security on the IBM? Well, at the end of the day, it really comes down to the data that you have on your machine. This is a very critical corporate asset for most of us. It's probably why you've invested valuable time to be here with me today. And it's critical that we have that environment secured appropriately. We want to make sure that those data assets are protected. It's not just about loss of data, right? We talk about data breaches all the time, and I guess I'm as guilty of that as the next person, but at the end of the day, it's also about business impact. How expensive would it be, whether financially or otherwise, to the organization if the data was lost or stolen, but also if it simply wasn't available to the application users, or that the database itself had inaccurate information upon which you're making business decisions? Part of the process is to evaluate the risk that you're facing, and that involves determining the scope based on the type of data that you're hosting, and into that we're going to factor in who has access to it, or at least who should have access to it. With IBM security, we tend to lean on three different areas of control. We, of course, have the users who are accessing the system. Arguably, nothing bad happens until a user connects. The question is that user connecting appropriately? Is it the intended user that's coming into the machine? And there's a lot of settings around that, predominantly on the user's profile itself, indicating what happens when that user signs in. What's the library list? What menu do they see? Are they allowed to run commands? And that's just on the green screen. We've also got to factor in the non-green screen environment as well. We also have object authorities. Some people call them permissions, although we usually refer to IFS as permission-based. In the native world, we tend to talk more about authorities. This is where users are going to gain access to application libraries, of course, folders, directories within the IFS, and the contents of both of those types of containers. And then we also have system values. These are system-wide attributes that control the behavior of many facets of the operating system. And there's quite a few of those system values that are specifically revolving around security. When we talk about OLS, object level security, it's really considered the gold standard of security on IBM. So one of the things you need to ask yourself, or maybe are working towards, is this the first step in your mitigation plan, or is it arguably the last step? There's a couple of different ways of looking at OLS, and I've kind of broken down 4 different pros and 4 different cons here. So on the pro side, things that I feel are very beneficial around OLS is that in many instances, implementing it is a lot easier than I think people expect. Yes, you can get very granular and very micromanagey around object level security, but in some instances, all we have to do is secure the library that contains the database objects, and it's problem solved, right? So it can often be easier than perhaps you're expecting. The best part about OLS is that it doesn't matter the type of access method that you use, it's going to be respected. It's going to be checked by the operating system. So while sometimes we talk about PC interfaces like FTP as quote unquote backdoors into the system, it's simply because we haven't defined object level security, and therefore the user has access to things that we weren't expecting. Object level security is very definitive. So if you are subjected to a regulatory mandate or you have some type of formal audit in place, then this is arguably going to be the thing that people go, oh, you have restrictions on the objects, that's great. If you have shied away from object level security just based on the fear that many of us have that by implementing it, we're going to break a perfectly working application, then you will be reassured to know that as of version 7.3 and enhanced in version 7.4, IBM has included some tools to assist you with the task of determining the appropriate level of permission that you need on your application objects. So recognizing that a lot of people were hands off with OLS because they were fearful of it, they have given us ways to kind of take some of the guesswork or the speculation out of the process of implementing it. Now, on the negative or the con side of things, while I say it's easier than a lot of people think, it doesn't necessarily mean it's easy, right? So there are concepts that we're going to talk about today, at least at a relatively high level, that sometimes throw people a little bit for a loop. So hopefully I'm going to present it in a way that makes sense to you. Certainly welcome any feedback if you know, you think that is a good way or a bad way to do it, and we'll accommodate that going forward. One of the things about object level security that frustrates people that have worked with it is that it's not very flexible. OLS was designed into the original operating system OS 400 clear back in 1.0, arguably even prior to that in the system 38. But really what it accommodates is a single method of accessing objects. And in the mid-90s, when IBM gave way to our pressure and implemented TCP services and gave us FTP and ODBC and DDM and others, all of a sudden the operating system didn't have a way of detecting the difference between those interfaces and potentially giving a user different permissions. So arguably, open the door to one interface, I've opened it to all. Secure one interface, I've locked them all down, right? So I can't set any kind of variety there, and that can be challenging. There are other options that often come to the table that may be quicker, arguably more effective to implement, right? At the end of the day, it's still the gold standard, but if I can accomplish resolving, let's say, 80% of the risk problem and only take 20% of the time or implement 20% of the steps, that's going to be very appealing. So there are other options that need to be brought up in conversation as potential first steps, and we kind of target object level security down the road. I've also listed here that it doesn't solve 100% of the security problem. There's more to security within IBM and virtually every operating system than just object access, right? Things like auditing. And so object level security doesn't address all of those things. And we need to have a game plan for that as well. The first thing in the step of protecting data is to determine the default amount of access that's going to be given. We talk with terms such as deny by default or least privilege, and these are buzz terms in essence that basically talk about the fact that there is a door into the system. And do we want that door to start off closed, at which point we allow people in based on their necessary access? Or do we start with the door wide open and potentially kick people out who shouldn't be there? Now, the intent is that we're going to specifically authorize users that need to access objects. And that deny by default model is really your target, in my opinion, that you should be going after. But the unfortunate nature of IBMI is that it is typically in the complete opposite configuration of that. We tend to allow everybody in until we say otherwise. Now, it's not all on your shoulders there. IBM actually sets the permission, the default permission in the operating system as start change. We're going to talk more about what changes and the implications of that as we go forward here. Your decision making is potentially going to be driven by outside forces, whether that's a regulatory compliance mandate, whether it's some type of formal legal requirement, or you're just doing the right thing. The best practices are saying we can't have this system wide open. We need to have it in a kind of least privileged state. In order to utilize an object within IBMI, a user has to be given sufficient authority to that object. And the authority can be gleaned from four main areas. All object special authority is a permission, an administrative permission that is granted on a user's profile. If the user belongs to a group profile or multiple group profiles, all object along with the other 7 special authorities will be inherited from the group. Private authority is explicit or named permission that has been given. Robin, you can see this data, or Robin, you can run this program. It can also be excluding somebody. So Robin, you're not allowed to touch this file, but it's specific to me or a group that I belong to. In the absence of either of those first 2 steps, then we also have public authority. That's the default permission that I mentioned just a moment ago. Public authority is really not an authority per se, but it's an authority that is granted to every user on the system that doesn't have any more explicit definition. So it's a catch-all, a default authority. So if you've heard the term public, you've thrown it around, it's really just a default permission. And then I also listed number 4, which is a programming technique. I listed it here as a trick per se, because it allows a programmer to temporarily grant a user permissions to objects that they would not normally have if they went at that object directly. So it's a very valid technique that allows us to provide good control via an application, but it's also something we have to consider because it can be abused. It can ultimately be a Trojan horse, allowing a user to get to things they shouldn't have. So we'll talk about that a little bit as well. The IBM I operating system breaks authority down via 4 predefined authority templates. The intent of these templates is to make our life easier, right? So I've listed the templates here, starting at the bottom and working your way up from the least amount of authority, which is explicitly exclude, up to use permission, which allows us to see data, run programs, then to change, which allows us to run those same programs, not only now see the data, but also modify it and delete it. And then ultimately the most permissive of all the templates, which is star all, which not only lets me do all the things to the data, but it also lets me control the existence of the object itself. Now for you, you probably think of the database as your main asset, right? And in terms of files, there is not a massive amount of difference between change and all. So that change permission is going to let me see, modify, and delete data in the file. All is going to step that up so that not only can I delete the data from the file, but I can delete the file itself. But sometimes it could be argued that if you've deleted all the data out, arguably the damage has already been done. Who cares if the shell of the object is still there or not? The templates are designed to allow us to quickly and easily indicate the appropriate level of access based on those very simple kind of breakdowns. What this is doing under the covers is indicating which of the more granular controls are being assigned, right? So rather than you have to micromanage all the individual permissions that you see highlighted here, we can now just use the template and say this is an appropriate level of access. There are endless combinations. So you do have the ability to override, in essence, in a way that does not align with a template. But my recommendation is whenever you can, use an IBM template because it means that it's going to be more clear cut. If you have 4 options against the file, that's going to be much easier to manage than if you have 427 different combinations of different things for different files. Right? I've kind of highlighted this control already, but I do want to point out the exclude permission. People go, why do you grant the permission to do nothing? And the answer is public. Because we have that default permission that will catch it, if we don't explicitly say exclude, we have to have that option to lock somebody out of a place they shouldn't be, right? Now, the thing to note here is that that object is not accessible unless the user is carrying all object special authority. That is arguably the keys to the kingdom, the skeleton key of your database. And it allows a user to access the objects on your box, including those in the operating system, in any capacity that they wish. And then the other 3, again, stepping it up. And I've made some notes here for you to reference as far as what a user potentially can do by leveraging those existing predefined templates. When we look at the granular authorities, we can kind of group them into 2 different sets. There is a slight nuance difference whether it is a native object, something like a application RPG program or a physical file, versus objects that are in the integrated file system. all right? But for the most part, what I've highlighted here tend to be referred to as the object authorities. For the very simple reason, they're controlling what you can do with the object itself. Object existence, for example, controls the ability to delete the object. Object management allows us to do different management tasks, maybe put a trigger on it, things like that. When we break those down into their individual components, again, in the interest of time, I won't read through all of this, and I just wanted it to be available. If you are interested in grabbing a copy, we can make that available. But in essence, I wanted to document some of the steps that you can accomplish if you have these various different object permissions. In addition to the object authorities, we have data authorities. I think for most people, this concept is a little bit easier to grasp. The idea that I can write records to a file or I can delete records from a file. In the case of execute, it's the ability to run a program. Now, reality is execute is a data authority on every type of object, but you don't run a file, right? So it's just simply the ability to touch the object and to gain access to the contents based on the other data permissions that you see there. Again, documented here for you. Usually, again, this is a little bit more intuitive. I think the ability to pull data into a program or write data out to a file, these are things that I think people have a pretty good grasp of. Now, users are getting their permissions, as I mentioned, from those 4 stages. But one of the things that I get asked about a lot is when a user belongs to a group profile and what is there as conflicting authorities. Now, in the case of a user versus a group, then it's very important to understand that a user, an individual, is going to take precedence over anything defined in the group. So if I have a permission, Robin is, for example, set with use permission to allow me to read a file, and I belong to a group that is excluded, I'm still going to be able to read that file. And vice versa. If the group is permitted, but I'm not, then I won't be able to read that file because it takes my permission first. I'll break down that hierarchy for you here in a moment. With multiple group profiles, understanding that a user can belong to up to 16 total groups, we have to understand that it's an inclusive or relationship between the groups. And to help paint a picture, I've drawn out here where a user belongs to group A and group B. And in the case of group A, they have all permissions to a file. And group B is specifically excluded from the file. When we draw out the X's to show what permissions are associated with the all and the exclude template, what we do is an inclusive OR test. And so the net result, arguably, is the equivalent of star all. As long as there is an X in one, or arguably both of the vertical boxes, we're going to carry that down into the result box, right? So in this case, I get the benefit of the most permissive group combined. When a user asks to access an object, it's actually going to pass through a couple of different levels. And again, representing it here, hopefully to make it a little bit easier to understand. The first thing the user has to be able to pass is the library or folder test. In other words, the operating system is looking at the object's container to determine if the user has permission or is explicitly excluded from that object. If the library or folder has been set to exclude for that particular user, then access is going to be denied, independently of how much permission the user has to the individual object inside. If the user passes the library or folder test, then the operating system will then take a look at the individual object being requested and determine whether the access is appropriate based on the object's own settings. So that 2 layers is very important to remember. And it also is the key, as I said a little bit earlier, to this sometimes being a lot less complex than people fear. If I can constrain a user so that they can't even access a library, I don't really care about the settings on those 10,000 objects inside. I've secured it by one setting, really beneficial. Now, it's important to understand that the search order that IBMI uses has multiple facets to it. So I'm going to break that down for you, but I wanted to start with a note that just reiterates that the authority checking algorithm will stop as soon as any applicable authority directive is discovered. Whether that is an authority that says, yes, you can do this, or one that says, nope, sorry, you're not allowed to do this. As soon as it finds a setting, it's going to be done. We're going to start with the user. the user is going to be tested to determine whether it has all object special authority. If that's the case, it's game over. That user is in, they can do arguably pretty much whatever they want. In the absence of all object, then we're going to check private authority for the user. Robin, you can do this. Robin, you can't do that. And if there's no specific private authority on the object, we'll look and see if the object is secured using what we call an authorization list, more on that later, and determine if the user is listed there. If we've made it this far and we do not yet know how much permission this user should have, we're going to keep going. Now we're going to check to see if the user belongs to a group. We're going to test, if that's the case, whether the group has all object special authority. That's important because, as I said earlier, we will inherit any and all special authorities that belong to any and all of the groups. Now, there is a slight nuance here with the all object in that, as you can see in the search order, a private authority for the user is going to take precedence over all object inherited from a group. That's a good thing. Although one could argue it's merely a speed bump because as a user with all object via the group, I can run a job as somebody else who's not me and gain access to the object that way. Now, if the group doesn't have all object, then we're going to check a thing called the primary group. That arguably is a performance enhancer within the operating system that allows us to shortcut some of the other checks. Doesn't really influence the amount of authority. It's just going to speed the checking algorithm up. Really what we're doing is checking for the group name being listed specifically. Group A is exclude, for example. If group A isn't listed at all, we'll also check an authorization list if one is in play, and we'll look and see if the group is listed there. Again, I'm going to give you more information on what authorization lists are as we get into the session here. If we still have not yet determined how much authority the user has at a group level, then we're going to check every group in that cumulative inclusive OR way that we talked about. And we're going to add up any authorities that the groups have, or we're going to determine that there's no more groups left to process. And if I'm still left hanging, I don't know how much authority the user has still, then I fall into the third and arguably final specific layer, which is referred to as public. Now I've got here object or authorization list. The public permission can only come from one or other. I'm going to show you some screenshots to paint a picture around that to help it be a little bit easier to absorb. But it's important to know that the object has a public permission or it comes from the authorization list, but it can't come from both. Now, if we've made it all the way to the end and the permission is insufficient, so even at a public level, we found that the user has insufficient authority to do what they need to do. There is one last technique that we can use in order to qualify the user, and that's the adopted authority. That's the tool that the programmer can employ to say, when the user is running my program, I am going to now include the authority associated with the owner of the program. So if the program is owned, for example, by QSecOffer, we are now going to circle back around and do the authority check again based on QSecOffer being in the mix, right? Now this is an optional step. It's controlled by the attributes on a program. Again, we're going to look more at this to give you some specifics, but it is an optional step and it's a last gasp effort in a way to qualify the user to be able to access the file. But in this case, I find that very beneficial because it means if the user used the approved application, we can get them in. But if they go directly against the table from a command line or a query or some other method, then we have the ability to restrict their access. Now, if you're interested in getting a copy of the authorization flowchart that IBMI uses, send me an email and I'll be happy to send you that as a one-page PDF. If you're shy or if you have access to the security reference manual, it is contained in there. Granted, it's not quite as colorful as the one we created, but it still has the information. And we've simplified it here. This one pager actually gets broken down into multiple sub flowcharts. So if you want to know explicitly how IBMI does its thing, then go to that security reference manual. But if you just want a generalized summary, which will give you great background in how IBMI is determining whether a user should or should not perform the tasks they're doing, this is a great start. And I would pin this to the wall. And if you can get this down in your head, you are well on your way to being an expert in object level security. No conversation about OLS is ever going to be complete without discussion of the situation of over securing an object. It's just the reality of what happens. Now, with the tool that I mentioned we introduced in version 7.3 and 7.4, one could argue that there's no longer an excuse for it, but I get it. The reality is at some point you will over secure an object. If you're not using adoption to get that user up, or you've recompiled the program and forgotten to set that elevation attribute, the adopted attribute, then a user is potentially going to receive an authority failure message like this, a CPF 2207, which is not authorized to use object X in library Y. It's also going to generate what we call an AF entry in the audit journal. If you're not familiar with the audit journal, just know it's IBMI's flight data recorder. It's something you have to turn on, and hopefully you guys all have. If you haven't, if you don't know what I'm talking about, then there's content on the help system site about how to do so, or you can certainly pop a question in the chat window and we can get with you about how to set it up. Arguably, it's a single command, but there are some nuances in how it should be set up versus the default settings. So I do encourage you to do a little bit of research just before you slam that one command and find you're in a situation you don't want to be in. That AF entry is going to be logged each time an object access is requested and the user has insufficient permission. So it's a very important thing to understand, not only from debugging or troubleshooting, but from the fact that you got a situation where somebody's trying to touch an object they shouldn't. The answer or response to an authority failure is not to give the user all object special authority. Will that fix the problem? Absolutely. But it's like trying to put a finish nail in with a sledgehammer. One could argue there's little more overkill than that. So the all object option will work. If it's 3 a.m. and you're trying to get payroll run and it's throwing authority failures, one might be able to justify this response. But in general, the recommendation is determine why the authority failure is occurring and correct the root cause. Don't just put a Band-Aid on it by giving the keys to the kingdom. Speaking of all object special authority, so this is, as I've mentioned, an administrative privilege. It's granted to the user. So if you take a look at your user profiles and look at the attributes on, there is a parameter called special authorities, and it will either be defined there, or you also need to check if the user belongs to a group profile. Now, I see there was a question in the chat about a supplemental group. Supplemental groups are just treated as additional group profiles. Right? When IBM originally created the concept of a group, you only could assign a user to one group. Subsequently, they added 15 more. But rather than tamper with the original parameter, they just created a secondary parameter on the profile. Arguably, they're all treated equally. So when we do an authority check, or when we look at the inheritance of special authorities, then all of the groups are arguably treated equally. Having all object is going to give the user the ability to literally access every single object on the system, including those that are part of licensed program products, that are part of the operating system, that cross application boundaries, and even other users' profiles. In fact, if you're carrying all object as a user and you have a method to exploit or run a command, then it's game over from a system perspective. I did a evaluation with a customer, security scan, last week, and had to explain, unfortunately, to them that their prevalence for giving all object and the ability for users to run commands meant that with one single stroke, I could destroy their system. Needless to say, they're now endeavoring to rein that number of all object users in. And because all object gives you permission to other users' profiles, indirectly, I can gain the other special authorities. Now, if you think to yourself, hey, I'm an admin and I can't give myself what I don't already have, you're absolutely correct. But with all object, what you can do is say, run the job as somebody who does have those permissions and have that job give me the permissions, right? So it's an indirect approach, but it's a very quick hack for people that you want to ensure is not sitting in front of your users. All right, so that's all object. The next bullet we covered at a high level was private authority. So let's talk about that a little bit because it's an important concept. This is the named or explicit access that I introduced. It's given to a user. It's also potentially given to a group profile. Now this contrasts the public authority, which is the default access. So this is explicit to a user or a group. Certainly, private authority can be more restrictive than public permission, but it typically is done the other way around, right? When we talk about that deny by default or the same least privilege concept, what we're talking about is we want the door to start closed and be open to the permitted users. So that would equate to public authority being something like exclude, and then private authority gifting access in a more permissive way. When we look at an example object on the IBM, we see examples of private authority. So this is a display object authority command. There's also an edit object authority command that allows us to make changes here. And then the IFS has its own command equivalent. So display authority, edit authority. In this case, a profile called read-only has been given private permission to this particular file at a level of star use. So we're taking the advice and we're using a predefined template. In this case, read-only is allowed to see data in a file and to run a program, but nothing beyond that. Here are the commands we use to give somebody private authority. It's grant object authority and edit object authority on the native side of the house. And then change authority can do that for integrated file system objects. So I threw an example here of a receivables file in a library. It's a native DB2 file, and I've granted Robin use permission to that particular file. If I want to revoke that permission, I can do it in two ways, actually. I can grant exclude permission, or I can remove the existing permission, which basically replaces whatever's there with a new permission. So in this case, I've revoked the permission to the receivables file, and I've stripped off all permission. Right? No object level security discussion is ever complete without an introduction and a recap of this public authority that I've mentioned several times. It's unique to IBM. No other platform kind of has this default permission per se, which is why it tends to throw people. Public authority is how much a user is going to be given if they are not explicitly told what they have. This is going to be granted to a user based on their profile or based on a group. Now, the public authority is going to be determined through several steps. If it's a native object like a DB2 file or an RPG program, it's going to originate from the create command. If it's in the integrated file system, public authority is inherited from the parent directory. So if we look at native objects, because that's probably in reality more of what you're going to be touching on, I've drawn out here the three levels of hierarchy. So the create command, whichever that may be, create RPG program, create physical file, create data area, they all have a parameter on them called authority. That's the public authority. And the default setting on all those IBM supplied commands is lib create authority, which is a directive that says go up to the library attributes where you're creating this object and check there, because there's an attribute on the library that tells us the default public permission. Now, the library creation default, if you've just created some libraries and not overridden it, is going to defer again. This time it's going to defer up to the system values of your IBM. And that system value is the third and final level. There is a system value on the box called Q create authority, and that's where it's going to grab it from. Now, it's important to note that this is not a dynamic relationship, meaning that if I create a physical file, it's going to do this check as far as it needs to. And once it grabs that public permission, it's going to assign it to my new object. And if I subsequently change the Q create authority system value, that will have no impact on the object that I previously created, right? So it is not a dynamic link. Now, conceptually, there is absolutely nothing wrong with public authority. I'm actually a big fan of it. The challenge is that the Q create authority is predefined by IBM as a value of star change, which I'm not a fan of, because that means that if I just create stuff willy-nilly on the system and I don't override any of the public attributes, the authority settings, that change permission is going to allow the user to run programs, see data in a file, change data in a file, and delete data in a file. One could argue that there's very little extra that a user could ever need to do beyond that, and that's the default permission that we've been given. One thing that you can do is actually not use the full hierarchy. There's a very good chance that you have more than one application being hosted on your IBM. Right? right? And in that instance, why would we want the public authority to come down from one central point? Application A may have very different security requirements from application B. So what I recommend is, yes, allow the create commands to generically inherit from the library attributes, because otherwise there's going to be a lot of micromanaging there. But then set the library attributes to not inherit from the system value, but to have an appropriate default public authority that will be given to all of the objects created in that library. That gives us the best of both worlds. Generic control from the create commands, but it's now going to allow us to centrally set it based on the application library. Bear in mind that every single object has a public permission. In this case, the public authority is set to a beautiful value of *exclude. So somebody here has overridden this from the normal shipped IBM default. We have to talk about authorization lists when we talk about these permissions, because that tends to be a confusing control. I hear from people, oh, we're secure because we have authorization lists. But an authorization list is not a security setting. It's a mechanism to assist with organization. The intent is that instead of setting the authorities, whether private or public, on, say, 150 individual objects, I attach those 150 objects to an authorization list, and then I can just set my settings centrally in one place. All of the objects that are secured by an authorization list are going to get their private authorities from that list. Optionally, they may also get their public authorities from that list. If you remember, I said when we get down to the authorization list, it's an either or scenario for public. You can't have both. You can still give people specific authorities that will then be exceptions to the authorization list. So let's say we've got those 150 objects and we have public *use to allow people to read the data. It's all being controlled by one single authorization list, which is a management joy. And then a user comes along that needs slightly more permission. I can still gift that user more permission on an individual basis that would be an exception to the list for a particular file. So just know that we do have really well-designed security controls here, and an authorization list is making it easier for me to work with them in order so that this isn't a frustration. Authorization lists all live in the QSYS library. So when you create one, you don't have to designate a library name. And what you specify is the public permission on that authorization list in case you optionally defer the public setting to it. We then have a couple of commands, edit authorization list or edit authorization list, to maintain the entries on the list. One of the biggest benefits of authorization list is if you're a 24/7 shop. You've probably figured out, if you've ever played with object level security, that it requires you to get a lock on an object to make a change, which when you're 24/7 isn't going to make you very popular. However, if you pay the piper one time and get an authorization list attached to that object, you can subsequently make changes to that authorization list without requiring a lock on the actual object itself. And that's a huge benefit and a big win for people that need to keep those applications running. Here's an example of an object that is not secured by an authorization list, which means that the public exclude and the two private authorities that you see here and being pointed at from the blue arrow are the only permissions that are coming into play. If we attach an authorization list, instead of being none here, we have the name of an authorization list called payroll. The option is now that we have not only the public and private permissions you see, but the operating system will also verify if there is an authorization list entry that applies to that user. And there's a little bit of ricochet back and forth. So an individual is tested here privately, and then it'll look for a private permission on the authorization list. Then it'll come back here and look for a group. And if it finds it, great. If it doesn't, it'll go back to the authorization list. And then ultimately it'll come back here and look for public. And if the public directive says authorization list, it will go one last time to the authorization list. In my example, it doesn't say that, it says exclude. So the public setting on the authorization list doesn't come into play. Right? So know that these permissions are going to take precedence over anything defined on the authorization list. And if we want the public permission to come from that authorization list, We put a value in here of star AUTL, which gives it that last breath directive to go over to the authorization list and get the public settings from there. If you're currently using group profiles or you're using authorization lists, I'm sure at some point somebody has asked you, or maybe it's crossed your mind, that you're wondering whether you should use a group profile or an authorization list. Because I hear that question over and over and over. And at the end of the day, it's not a choice that you have to make. You can use them both. They're slightly different from one another. They have a different overall purpose. As a recap, a group profile is designed to associate users that have similar security requirements. So all of the users in an order entry department or a part of human resources. An authorization list is also an organizational mechanism, but it's designed to secure objects that have similar security requirements, such as all of the objects in an order entry system or all of the files in a payroll system. The benefit of combining the two is that it will simplify your life greatly. In the before image here, let's say I have 100 different users and 100 different objects. That means I'm going to have potentially 10,000 grant object authority directives to get that set up. And no, if you say to yourself, there is no way on earth I'm ever going to bother with that, you're not going to be alone in that camp. I will be the leader of that group. However, if we have the luxury of assigning those users, even to multiple groups, but let's say it's magic and we can make all 100 users part of one group profile. And all of those objects, those 100 objects are, hey, very similar to one another. They have the same level of access requirements. And we can put them on a single authorization list. I can now accomplish, instead of using 10,000 specific commands, I can do it with one by granting the group profile permission via the authorization list. Talk about making your life easier. Now, I promised that I'd talk about adopted authority. I wrote application code for many years early in my AS400 career and still look very fondly upon that time. And adopted authority was something that I used frequently. Now, the trick with adopted authority is to understand, first of all, that a program normally executes only with the permission of the user who invoked that program. Makes sense, right? If Robin calls the program is giving me access to anything that I have access to. As I mentioned earlier, when we go through that authority check, if we get to the bottom and public says, nope, you can't do this, then adoption will give us that last chance because it will come into play if the authority checking algorithm determines that the user in fact does not have the appropriate permission on their own profile. The adoption then will look at who owns the program that I'm running, and it will increase my permission based on the authority of that program's owner. Now, if the program's owner has the same or less permission than me, the net effect is nothing will really change and I will get an authority failure. But if that program owner has more authority than me, then it's going to allow me to run the restricted task, but only while that program is running. So as soon as the program ends, I'm back to just plain old Robin again. Right? So it's a really great technique that programmers can leverage in order to facilitate temporary authorization. If that program is part of an overall application, then there's probably a program calling a program calling a program. So we have multiple application objects within what we call a call stack. And the authority can be passed down from program to program, which makes it really beneficial if I simply do the authority adoption in the first program in the call stack. It will flow down the stack, so I actually don't have to do a whole lot of configuration in the subsequent programs. Some nuances around adoption that I wanted to make sure I shared with you. First of all, is that the authority is only additive to the user, meaning that we can't reduce permissions with this technique. It also doesn't carry through to the integrated file system. So if a user is running a program that adopts authority and then tries to create a stream file or access contents in a stream file that the user themselves does not have access to, the adoption is not going to help. You can use a swap profile in that scenario, so there is an out and it's a beneficial one. It's also worth noting, as I mentioned, that the authority can be adopted from programs in the stack. Now, if those programs have different owners, then we can now introduce authority from different owners into the mix. Arguably, it can get a little complex, but the vast majority of times people keep it very, very simple and it works extremely well. My hot tip that I wanted to share was if you do have a program that is running with adopted authority, potentially giving the user more rights than you have explicitly given them, never drop that user into a screen that has a command line as part of it. Don't take the user out to a work spool file because that adoption will carry through. The appropriate response there is if the user does need access to that screen, put the work spool file command or whatever it is in its own program, and then we can tell the system don't pass the adoption to that last program, in which case it cuts it off and the command line is back at the permissions of the user. Let me show you how this works. So here I have the program attributes, in this case of a CL program. When I compile the program and prompt the parameters or come back after the fact with a change program command, I want to point out this user profile parameter. By default, it's going to be star user, which means only utilize the permissions that the user has, the calling user. This program has been changed to have a value of star owner, which means if the user has insufficient permission, then the owner will come into play. In this case, it's owned by QSEC offer, and this program will run with the added permission of this target profile, right? Again, it only comes into play if the user doesn't have permission on their own. There's another parameter that I want to point out immediately below the user profile, and it's called use adopted authority. And I get very puzzled looks when I point this out, or users who think this controls adopted authority. And you would absolutely be forgiven for thinking that's what makes it yes or no and turns it on. But actually having a yes here is simply the conduit that allows this program to take advantage of any adoption that was already in place, put there by programs higher in the call stack. So this is kind of a use inherited adopted authority setting rather than turning it on and off for this program, right? So an important distinction between those two parameters. Let's plan that out as a picture. So I've got three programs in my application, A, B, and C. Program A calls program B turns around and calls program C. When we look at the authority checking on the right-hand side, we see within program A, it's going to check the calling user first, and then it's going to call in the permissions associated with app owner. The reason being that the program is owned by app owner, and the user profile attribute on the program says star owner. When program B is invoked, we end up with the calling user being validated first, then app owner. Because the use adopted authority attribute is set to yes, it's going to take advantage of the adoption already in place higher in the call stack. So that's coming from program A. And if still insufficient, then we're going to leverage the permissions of this object's owner, in this case QSEC offer, because of the user profile attribute being set to owner. So it's very flexible because you can control these parameters individually. In fact, when we get to program C, we'll see that we're back to only applying the permissions of the calling user because the use adopted authority attribute is set to no, which means it's forgetting about what was placed there by program A and B, and it's not bringing in the owner of program C because our user profile is set to user. It's all a bit of a mouthful, but at the end of the day, it works very logically and it is extremely beneficial. If you can get this concept kind of in your head, then you will be very good at designing secure applications. Now, before we get done, just a few considerations that I want you to think of. If you are an application developer, you want to consider if you are creating objects on the fly as part of the application runtime environment. Once an object is created, whether it's a work file or whatever, if that is a perpetual object that may need to be accessed by other users of the application, then it's important that you set the correct authority settings and potentially object ownership for that object. It's worth noting you can't create new objects in a library that only has use permission. It's important to note as part of that, that I can still delete objects from a library where I only have use permission. Now, that's counterproductive to a lot of people. Think of it this way. I have to get through the library layer first. Remember, we got the rubber stamp. Once I'm inside the library, everything's controlled by the individual object. So if I have delete rights to a file, but use rights to the library, I can still delete that file. I also can't create new members in files if I only have use permission to the file. So if you use multi-member physical files, you'll want to do a little bit of testing and understanding in a bit more detail than we have time here today. Make sure that you don't just secure your application objects, your database, but also your source code. You don't want people changing your code or taking it with them. So make sure that your source code is in a protected state, just like your application databases. You should audit any access attempts against highly sensitive objects. If you've got a payroll master file, pretty obvious, right? Make sure you have auditing turned on for that sensitive object so you know exactly who touched it. And ideally, you have auditing configured in a way that if somebody tries to touch that sensitive object without the necessary permission, then the system will log that as a violation. So you have to have the auditing function turned on, the authority failure event type included, and then you'll be looking for those AF entries in the database. It's important to note here that an AF entry will only be generated if you have a profile configuration conducive to that. I've had a customer tell me, we've never had a data incident because I check for authority failures every day and we've never had one. And we looked at their profiles and everybody had all object. So I told him, don't waste your time looking for an AF entry. They'll never generate one. What are your next steps? Well, there's lots of things we can do to help you. One of the things that I always offer to people is if you've not done one before, or if it's been at least, I say 12 months, have your system assessed for any of the common vulnerabilities. Help Systems does this for free. In fact, I'll make that offer to you in just a second. You can answer a quick poll question if you'd like that done, but it consists of running a specific tool on your IBMI, which can be run in the middle of the day. It takes a minute, maybe two to run. And then we'll spend about an hour with you at no cost and explain all the findings to you. So it's consulting time from an expert and also a tangible report that's yours to keep. You should determine if object level security is one of the appropriate mitigation responses. There are other things that can be done and possibly more quickly. So is object level security on your radar, and where does it fall into the hierarchy or order of things where that mitigation is going to be applied? If you're not familiar with the State of IBMI Security Study, I recommend downloading it. We're working on the new State of Security Study, but there's always one out there, and I would offer that will give you valuable insight into what other people are doing or maybe not doing in terms of IBMI security, and it'll give you a foundation of where you can look at for good information for your system. There's also a CIS benchmark for IBMI. These are directives that outline minimum basic requirements for different devices, and they now exist for IBMI. As long as you're on version 7.2 or later, there is a benchmark for you. Prioritize all of your activities around mitigation so that you have measurable goals and attainable timelines. This isn't a motivational session about how to get more done in the day. Lord knows I would benefit from that, but really what it comes down to is don't try to take this all on at once. We have arguably ignored IBMI security for 30 years, and we've got some catch up to do. And so reality is you're not going to get it all done overnight, so we have to prioritize and make progress one kind of step at a time. If you have the necessary time and expertise on your hand, go for it. If you don't, like most people, then a good option is to partner up with outside experts. And we have people that specialize in the operating system, as well as, of course, all the help system software products that we have in our portfolio. If you have forgotten, or if you signed up a while ago, remember there is a part 2 to this conversation. We're going to talk about some of the limitations of object level security so that you can see both perspectives. I'm a fan of object level security, as you may have picked up. I've spent a lot of my career working around configuring it and making it work, but I get that it's not always a #1 option for people, right? Whether it's intimidation, whether it is just the fact that we think compensating controls are effective. We want to walk through some of those kind of con side of it. So we wanted to share both perspectives with you. All right, with that being said, if there are any questions, and I'm going to take a quick look here and see what's come in, please feel free to use that question panel and we will get that. All right. Roger asking, is part 2 at the same time? Yeah, I believe it is. Should have a link to that. If you don't, feel free to reach out and you can get that. What is the link to the IBM security review object? I'm not quite sure what you mean by that, Roger. Maybe you can give me some clarification on the question. Chris, you were asking about how the supplemental group authority security check works. So I kind of dropped that in because I saw your question as I was talking. And really what it comes down to is all groups are created equal at the end of the day for the most part. So I don't care if it's the primary group or if it's a supplemental. It's a cumulative thing on the private permissions, and all of the special authorities across all of the groups are going to pass down to the members. So you can arguably treat all of your groups as a single entity using that inclusive or relationship that I mentioned. Right. Oh, thank you, Roger. Yeah, you're asking about the product or service available from IBM that was introduced in version 7.3. It's actually not a licensed product that you have to buy. It's just part of the operating system, and it's called Authority Collection. It's something that you turn on. In 7.3, you can turn it on per user, and in 7.4, you can still turn it on as a user, but you can also turn it on an object level. And what that is going to do is start building information about who touches what, in essence, on the system. So it's going to give you information regarding the amount of permission a user has to the object they opened or touched, where they got that permission from. Was it a private permission? Was it through ALLOBJ? Was it a group authority, which is giving clarity to the kind of process? And then, and arguably the most beneficial piece of this, is that it tells you how much authority the user truly needed in order to accomplish the task. So in other words, you turn it on, you let this file build out, and then it's going to give you great insight. So all the speculation of yesteryear no longer applies. It's all very specific. Right? Now, it still takes quite a bit of knowledge of how to leverage the data. It's not a trace per se, but once you've got the basics down of how to use that authority collection service, then it's a great trick to helping you simplify the task of implementing object level security. Pablo asking me to repeat the advantages of group versus authorization list. Yeah, so my comment was they're not exclusive to one another. Use them both. Group profiles allow us to group together users with similar security responsibilities, and authorization lists allow us to treat multiple objects as a single entity. And if we combine those two benefits, that's where we went from the potential of 10,000 grant object authority commands down to one add authorization list entry command. Now, I'm arguably oversimplifying it. We all know that it may not be quite that simple, but it's definitely very beneficial. So combine groups with authorization lists to get the benefit of both. You don't have to make a decision as to which is the most advantageous. All right. All right, folks, I know we're coming up on the top of the hour. I appreciate everybody joining me here today. I'm excited for you to have access to part 2 tomorrow. And thank you for your questions. If there's anything that you think of after the fact, feel free to reach out. We would be happy to answer those. I'll give you the info at helpsystems.com, or you can go out to our website and make contact that way. And we would be happy to assist you with any of your security requirements, be it on IBM I or any other platform. So until next time, thanks everybody. Take care, stay safe, and we'll talk to you soon. Bye-bye.